In this lesson, I'll show you 3 examples on how to convert between mass and the number of molecules. In question 1 they ask, an aspirin tablet contains 325 milligrams of acetylsalicylic acid, which has the chemical formula C13 H18O2. How many acetylsalicylic acid molecules does it contain? The first thing that I want to do is find the formula mass of one molecule of this compound. And to do that, I'll take each individual atom, in our case we have carbon, and multiply its molar mass per one atom, which for carbon is 12.01 AMU, by the number of carbon atoms within one molecule, which is 9. Similarly, we have H, which has a molar mass of 1.008, and this can be found in the periodic table. Any periodic table will display this information. Multiply that by 8, and lastly, we multiply oxygen, which has a molar mass of 16.00 AMU, by 4. Let's go ahead and find out what this is using our calculator. 12.01 times 9 plus 1.008 times 8 plus 16.00 times 4. And this gives us 180.154. 180.154 AMU, atomic mass unit. Now that we calculated the atomic mass unit of one molecule of this compound, keep in mind that our number should only have 2 digits after the decimal place, because this number and this number had 2 digits after the decimal place. That being said, anything after the 5 is insignificant. Just keep that in mind moving forward, although we will continue to calculate with the 4 just to prevent any rounding errors. Remember also that the atomic mass unit has another unit that represents it, which is grams per mole. So instead of using atomic mass unit, we can use grams per mole. And with this number, we can do a lot. In fact, we've been told the mass of one tablet, which is 325 milligrams. And it's appropriate now to convert milligrams into grams because this is currently in grams. Or what you could do is convert this into milligrams, although I prefer to convert this into grams. So to convert this from milligrams to grams, we use the conversion ratio where 1 gram is equal to 1,000 milligrams. And I'll multiply this number by 1 gram over 1,000 milligrams. The reason why I oriented this conversion factor to look like this is so that this milligram unit and this milligram unit cancel out. Dividing 325 by 1,000 gives us 0.325 grams. With this, I can now multiply this mass of 0.325 grams by the flipped version of this, because remember, this number right here is technically a rate. We have this many grams per every 1 mole. So I can orient this in the opposite way, where instead of having moles at the bottom, moles will be at the top and the grams will be at the bottom. So I have 1 mole over 180.154 grams. The reason why I oriented it this way is so that this gram unit will cancel out with this gram unit, leaving us only with the number of moles. And that's important for us because moving forward, we'll be using Avogadro's number to give us the amount of anything you want. In this case, it's in atoms, but we want our answer in molecules. Now, if you're confused by that, let's do one step at a time. So I'll take 0.325 and divide it by 180. I'll use my calculator. 0.325 divided by 180.154. That gives me a very tiny number, 0.001804. 0.001804 moles. Next, I'll take this and recall that we have 3 significant figures here, and 5 here, and since we're dividing, we should end up with a smaller amount, so everything after this 0 is insignificant, although I'll continue to write that 4. I'll take this number and multiply it by Avogadro's number. 0.001804 moles times 8.022 times 10 to the power of 23 molecules over 1 mole. This cancels out with this, leaving me only with molecules. Let's calculate this now. Multiplying this number by 6.022 times 10 to the power of 23, we end up with our final answer of 1.086 times 10 to the power of 21. Remember, we should end up with 3 significant figures because this has 3 significant figures, and this 6 is greater than 5, so this number rounds up to 9. So we have 1.09 times 10 to the power of 21. If you want to find the answers to questions 2 and 3, make sure to watch part 2. So we'll see you soon.